Hello everyone, this is James Shore with another how-to video. I'm recording this on July 9th, 2015. In this chapter, we are looking at code safety, and in the last episode, we had just set up a lint tool, specifically JS_hint, for doing static analysis of our code. That means that now when we run our build with one command, it will check all of our JavaScript files for common mistakes, and if it finds them, it will warn us. That is incredibly useful. Now, in this episode, what I'd like to do is go through all of the gotchas that you can find in JavaScript. We're going to use the JS_hint options as a way of sort of going through the kinds of stuff that JavaScript can throw at you and talking about how to prevent it. The vast majority of these issues will be caught by our linting tool, which is why it's so valuable to have one. But to start out with, I want to explain this iffy. We talked about this in the last episode. This is the immediately invoked function expression. What we're doing here is we are declaring a function as a variable of sorts and then turning around and executing it right away. So it seems like it's the same as just running the code inside here directly. What this is doing, though, is something that is one of JavaScript's kind of weird quirks, which is that variables are created and appear in a scope. And by default, any variable you create in just a normal file like this runs in the global scope. That means that this high variable is put alongside all the other global variables in your system. And if you were to do something like, say, window equals foo, or some other variable that's also already defined in the global scope, you'll overwrite other people's stuff without realizing it. So, because we don't want our variables to be defined in the global scope, and by the way, that includes functions, we create this iffy to create a new scope. That's what this is for. This is to put everything that we do isolated from any other file we create and anything that's built into JavaScript. So that's the first gotcha, is that by default, variables are created in the global scope unless you put them inside of a function. Similarly, and we're going to run into this a little bit later, if you put a variable inside of an if statement, unlike other languages, where every block defines a new scope. It's called lexical scoping. JavaScript, the variables you define with the var keyword in JavaScript, they are defined to the closest function, which in this case would be this one. So this variable is the same as this variable. These two foo variables are the same. In a lexically scoped language, in most other programming languages, in fact, these two variables would be different. So when this if statement exited, foo would go back to being equal to the value of baz. Well, in JavaScript, down here at the end, foo is still equal to bar. This is something that can be dramatically unintuitive if you're used to lexical scoping and used to having a variable in here, for example, that just goes away. It's most commonly an issue with throwaway variables like looping variables like an I or something like that. So that's our first gotcha, is variable scoping. Variables are defined according to which function they are in, and if they're not defined in a function at all, they are part of the global scope. And that is, of course, the purpose of this iffy, to prevent our variables from being defined in the global scope. Moving on, we have this use strict. I mentioned this in the last episode. This prevents common errors. One of the most common things it prevents is, again, related to that global scope. By default, if you leave out the var keyword in JavaScript, this will create a foo variable inside of this function, and it will go away when the function exits. It doesn't pollute the global scope. However, if you leave out the var keyword, now foo is being defined as a global. And you will not realize this because it will work exactly as if you had typed in foo. So that's an easy mistake to make. Use strict prevents that from happening. JS_hint will find that kind of a mistake as well. All right, so those are a couple of gotchas. The reason we have these two things are to prevent gotchas. Now let's go into our lint options and really dig into it in detail. Now, as you saw in the last episode, we do have our automated build working. Lint can take a wide variety of options, and I have those brought up here with the JS_hint documentation. Let's just go through them one at a time. JS Hint's options can be broadly divided into two parts, those that make JS Hint more strict and those that make JS Hint less strict, that allow you to do things that it would normally prevent. In general, my preference is to make a linting tool as strict as possible around things that can cause errors. So I don't have it enforce style issues, but I do have it enforce anything that will actually result in errors on my code. And the reason for that is that it's much, much easier to remove a linting option or something that lint enforces than to make lint enforce an option in the future. If you have a really strict definition of what you're allowed to lint right now, then as people write code, assuming they're running the build all the time, which hopefully they are, anything that JS Hint was going to catch and complain about, they'll find out about right away and they won't do it. On the other hand, if you try to add an option in the future, people don't know that you're going to add that option. They might be using whatever it is that lint's going to complain about. So adding a new option or linting in the future means that you often have to go through all the files in your code base and tweak it and fix it, and it's really a hassle. So I tend to make my JS Hint options really strict to start out with, and then slowly relax them when I find the need, when I find that one is being too strict or just isn't useful. All right, starting at the top, bitwise. In JavaScript, let's go ahead and make just a dummy function to demonstrate these things. In JavaScript, you might occasionally do Boolean operations. You might say, for example, that A equals B and C or D. This basically says if B is true and either C or D is true, then A is true. So if B and C are true, A is true. If B and D are true, then A is true. And let's go ahead and define those variables. And that will lint just fine. Now, it's possible to make a typo where you leave one of those out. And this is no longer the logical AND operator. This is a bitwise operator that says, look at each bit in the number and perform the AND operation on each individual bit. It's very, very unlikely that you're going to want to do this in JavaScript. Now, honestly, it's not a problem if both B and C are Boolean values. If they're equal to just true or false, then this will work just fine. But JavaScript also does type coercion. So you can use a number or a string or whatever in these spots. It's not a good idea. You should just use Boolean values. You should just use true and false. But there are times in which it is convenient to use truthy values or falsy values. Truthy values means a non-Boolean that behaves like a true value, or a non-Boolean that behaves like a false. Sometimes you're going to say this variable and that one, and they won't actually be true and false. They might be numbers. And in that case, if you use the wrong operator, you're going to have a bug. So that's an error, and by default, lint doesn't catch that. So what we want to do is we want to add an option, the bitwise option, that says, hey, that's probably an error. Let's go ahead and catch it. And you can see that right there. Now our lint has failed. It has caught an error. Now, if it turns out that your code does use this bitwise comparison a lot, you can take that option back out. But again, I like to have my lint be very strict. Next one, camel case. This one is talking about how you name your variables. That's purely style. We're going to skip it. And in fact, they're taking it out of the next version. Next, curly. This says that you need to put braces around every block of code. So for example, you might have some code that looks like this. If foo, do something, and then do something else. This is an error. What this is really saying is that if foo is true, then we'll do something and we'll always do something else. Where the intention here is that if foo is true, we do something and then we do something else. And if it's not, we don't do either one of those. Let me go ahead and define these variables. So some people like to say that this is an error, and I agree with that. It is an error. So you might want to say, curly equals true. This will cause that particular construct to fail. However, in some cases, you have just a one-line if statement, like this. And in that case, what I like to do is put it all on one line. I feel that it makes the code a little more compact. And I do this actually a lot. It's really common to have a guard clause, that is to say something at the top of the function that says, if not, whatever, return, for example. That's a very common construct for me. It's called a guard clause. I do it all the time. And unfortunately, Lint will complain about that. So I don't actually tend to have this problem. I don't tend to forget to use braces when I have a multi-line if statement. So I actually do not include the curly option. You can, of course, it is entirely up to you. Next, enforce all. That just turns everything on. That's not really a good idea, and they're taking that out. Third, equal, equal, equal. It is in JavaScript. JavaScript does type coercion, which means that when you compare two values, like this, for example, it will try to convert them to be the same type. So if A is equal to 3 and B is equal to 3, let's actually make this go. Then it will convert these two to be the same type. I don't remember if it converts them both to be numbers or both to be strings, and say that they are equal. And there you can see it right there, equal. The problem is that type coercion, it's a bit tricky. For example, if you compare an empty array to a number, what are you going to get? Well, it turns out that an empty array is equal to 0. And there's a lot of really bizarre cases like that in JavaScript. So it's best not to compare different types, to just say, hey, we need to do strict equality. And the way you do that is with triple equals. My recommendation is that you always use triple equals for all comparisons in JavaScript. And to enforce that, I turn on the equal, equal, equal option in lint. So if I lint this, you'll see that it will compare. It will say that we need triple equal. And now when we say, does 0 equal empty array, the answer will be, no, they don't. And you can see that right there. So equal, 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 they are true. In order for me to demonstrate that, I have to comment that out. For equal, equal, they are true. For equal, 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 they are false because they are not the same type. And the same goes for a string to a number. This requires you to just be a little more aware of what your types are and how they're comparing. I strongly recommend it. Next, which version of JavaScript we're using? Let's skip that. For in, there is a little weirdness about JavaScript that when you use the for in keyword or the for in loop, it looks at the properties on the object and all of the object's prototype properties, which means that you can actually bring in properties that you wouldn't expect. As a result, I just don't use the for in construct at all. There are other ways to get all the properties off of an object, but lint does have the ability to force you to check to see that you're looking at your own object's properties rather than any of parent objects. You might as well turn that one on, but again, I would recommend simply not using the for in construct. Freeze. In JavaScript, it is possible to overwrite built-in methods. We don't want to do that, so we're going to turn freeze on. Function scope. As I mentioned earlier, when you declare a variable, it's actually assigned to the scope of the function. So it's usually an error to define a variable inside a block. By default, JS hint will complain about that. So I'm going to go ahead and leave this turned off. This is actually in the wrong spot. This is a relaxing option. This makes JS hint more permissive, not less permissive. Future hostile, there's some things that are reserved for use in later versions of JavaScript. Let's go ahead and turn that on. I've not seen this option before, but I don't think it will be a problem to turn it on. All right, we still have lots more to come, so I'm going to stop here, split this into a two-part episode. Next time, we're going to continue looking at the JS hint options and our JavaScript gotchas. Your exercise for this time is to look at the options for whichever linting tool you're using. Look through the documentation of options, decide which of those things are going to be useful to you, and think about what errors the options are trying to prevent and whether or not those are worth trying to prevent in your own code. We're going to look at more of the JS hint options next time. Thanks for watching, and I will see you then.